Okay, in this video, I'm going to break down the first question that we did in the previous, but I'm going to go through it very rapidly and I'm not going to read everything. So I see a table, and because I see a table, I'm going, you know what? Probably looking at a chi-square. If they're looking for a hypothesis test, this is probably going to be chi-squared. So let's see what it says. Says, do the data provide convincing statistical evidence? Whenever they say that, statistical evidence, they're looking for me to run some sort of hypothesis test. They say the word association, and I notice I have a table. If they say association and I have a table, I'm saying chi-squared independence. All right, between types of add and children's choice of snack among all children similar to those who participated in the experiment. So it says, write a few sentences describing the effect of each ad on children's choice of snack. The null, the type of ad shown in this type of snack are independent. Why? Because they said association, okay? And remember, I like doing HO as an equal, so that means they are independent. Type of ad shown and the type of snack chosen are not independent. Now, real quickly, we should probably take a moment and make a note to ourselves. This means are not associated, and this is are associated, because it says are independent, so are not associated. Are not independent, so therefore they are associated. Okay, so the children were randomly assigned that was given. We need to check our Goldilocks, right, which is right here. Not too big. 75 was our sample size. How did I know that? They told me, but I could have also added all these up and I would have gotten to 75. And there are more than 750 children who watch TV. N is less than 10% of the population. And that's what we were checking. Or therefore, N is less than 10%. And then we need to check all expected values are greater than 5. Well, I don't know that until I actually run the table, because I actually don't know it till I run the test. So here we go. So in stat edit, second button followed by the matrix button. And this looks like the X -1 on it, the matrix right here. Press enter, oops, second matrix, edit, the edit's, and then enter. Well, what size matrix did I have? 1, 2, 3 rows, 1, 2, 3 rows, and 1, 2 columns. So 3 by 2. Be careful that you don't count totals when you do this. So I have a 3 by 2. You never enter in totals. And I need to enter my data. Well, my data was 21, 13, and 22, 4, 12, and 3. I entered all that data already to speed this along. Boom, boom, boom. Then I'm going to quit out of it. Once I have it in, I'm going to second quit. And now I'm going to go ahead and run the test, even though I haven't done any work yet. And I'm looking for a chi-squared test. There it is. Okay, we only use the go for goodness to fit. This is not a goodness to fit. Press enter. Our observed is an A, expected in B. This is going to be always. Calculate. And I'm going to go ahead and write down those values. My chi-squared value is 0.29. My p-value is 0.0058. And my degrees of freedom, real quickly, how did they do that? They went 3 minus 1 times 2 minus 1. 3 minus 1 is 2. That's just 1. And there you go. And once again, if this had been a 1, it wouldn't have worked. That's why that would make it a goodness to fit. Okay? So this is degrees of freedom is 2. So we write down our equation, observed minus expected squared over expected. Degrees of freedom, I just calculated that for you. We plug, I need to get my expected values because we ran it, but we don't know what they are. So we're going to go back into the matrix. So second matrix, we're re-entering the matrix. They're like Keanu Reeves. He's just not quite as full figured. And we have 18.7, 18.7, 6.3, 6.3, and 6.3. So we have those values. These are our expected values. All of them are greater than 5. Now we've checked that off. So our conditions are checked off. And I'm going to use those to plug in. So my first value was 21. So 21 minus the 18.7 squared over 18.7. 4 minus 6.3 squared, et cetera, all the way down to the last one. Now you don't have to do it. It's mainly just so you have them in here, all right? Your order may be different, but do make this the first one, and this is the last. Beyond that, I'm not sure it matters what you do in the middle. And if you want to, you can do plus dot 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 plus. Now, I went ahead and calculated the contributions. For goodness to fit, the calculator will calculate contributions for you automatically, but not for test of independence. So how did I do that? I took 21 minus 18.7, I got some value and I squared it. And then I divided it by 18.7. So I know this one had a contribution of 0.28. Okay, we were off by a little bit. It wasn't perfect. And so they all added up to the 10.29. When we actually ran the test in the beginning, when we went stat test, chi square test, that's what we got, 10.29. Okay, so we added those up, we get 10.29. And we had a p-value 0.0058, which is less than alpha, so we're going to reject the null. So our p-value is 0.0058. We reject the null. There is sufficient evidence that alpha equal 0.05 to suggest that add type and snack choice are not independent, because we're going to select our alternative, and our alternative was are not independent. The add type and snack choice are associated. Notice these are opposites. You got to be careful. Are not independent, are associated. Okay. The next thing it asked us was write a sentence describing the effect of each add on children's choice of snack. Well, that's where they're looking for my contribution, which is right here. So although Choco Zuties ad produced results greater than expected, 21 versus 18.7, the impact was less than the group that were shown neither ad, 22 of which you chose the Choco Zuties. The Apple Zuties ad produced the highest chi-squared value of 5.16 and appears successful in persuading children who seem to have a predisposition to Choco. Why do I know they prefer Choco? Because of the previous one. As the actual was 12 out of 25 versus 4 out of 25. Okay, something along those lines. You need to spend a little time because I don't have time to break that down. If you want to fully understand it, you may have to read that a couple of times. All right, that stops that one, and I'll go on to another one in a moment.